Gimbal lock is technically a physical phenomenon in which you have a series of rings which can rotate about one another. To see such a device, visit Wikipedia. Wikipedia defines gimbal lock as the loss of 1 degree of freedom in a three-dimensional space. This loss of degree of freedom occurs when the axis of two gimbals are driven parallel to each other, essentially locking the system into a two-dimensional space. This can be kind of difficult to understand, so I'm going to explain this using Blender. Blender is a free open source software three-dimensional rendering program. So here you can see we have an X, Y, and Z coordinate axis system. We've defined our rotations here using the XYZ Euler angles. If I apply a rotation in the x-axis, rotation about the x-axis doesn't appear to cause any issues for us whatsoever because the x direction rotation is applied first. The y direction rotation is applied second. Let's see what happens when we apply a large rotation in the y direction. Can you see the issue here with the large y coordinate axis angle? Let's say I want to now rotate about the x-axis. You can start to see that there's a problem there, especially when you consider rotations about the z-axis. In fact, the z and x-axes are almost lined up with one another. So essentially, if I was to apply a rotation of 90 degrees in the y-axis, then my relative x and z axes are directly on top of one another, and this puts us in a two-dimensional rotation plane, where I can rotate about the y-axis, and I can rotate about the local z-axis. And if I try to rotate about the x-axis, I get that same rotation. So no longer can I rotate this about this local z-axis over here. So essentially, if I want to store my rotations as a series of Euler angles, say 90 degrees, 90 degrees, 90 degrees, if I then change my x direction rotation, I'm not rotating in the x direction anymore. Similarly, if I attempt to apply another z direction rotation, I'm stuck rotating in that same direction. And this really only occurs because we are storing these rotation angles. So let's consider quaternion rotation, which is conveniently located in this program as well. With quaternion rotations, all we are truly storing is an angle and a vector. And we're saying that we're applying a rotation about a particular vector by an angle. So I can rotate about the y-axis, I can rotate about the local z-axis, and about the local z-axis, and the x-axis. And I can continue these rotations, and because they're being applied, we're not storing three individual angles which define a rotation. We are not getting gimbal lock. These are remaining free to rotate about their respective axes. Similarly, we can define axis angle rotations, which is similar to quaternions, in which we have, as you can see, we define an angle and we have an axis about which the rotation is occurring. And as I rotate this gimbal, it changes the axis about which we are rotating. And so we're storing a vector and an angle, and we can avoid gimbal lock. So let's try this with a different configuration. Instead of applying an x rotation, y rotation, and then a z rotation, let's apply a z rotation followed by an x and then a y rotation. Here, I can rotate about the y direction, and everything looks fine, because the y direction rotation is applied at the end. If I apply an x rotation, then you can start to see that our z and y axes are now close to being aligned with one another. And again, we have that same gimbal lock scenario. So it all has to do with how you're storing these angles. If you're storing one transformation followed by a second transformation followed by a third transformation, then you have this potential to enter a situation where you have a so-called gimbal lock, where basically you can only rotate in two directions as opposed to rotating in three directions as you would like to in three-dimensional space.